All right, so have a nice day, everyone. In this video, I'll be going to give you a short example for the adjacency matrix representation in a graph. And I'm not using any Java.util package since that is not necessary for adjacency matrix because there will be no collections are being used. Now, in this structure, let me go ahead and just give me a second. Something going on here. Now, I declare a public class name, which is main, as you can see here. And after that one, I have a private integer adjacency matrix, which is the adjacency matrix to store the graph. So the adjacency matrix that signifies a two-dimensional array matrix, just to represent the adjacency matrix of our graph in order for us to store the edges between the vertices. After that, I also put the array to store vertex labels, which is under the private string vertices. The our and which is this is an array of strings to store labels of the vertices, as what I mentioned here. And we have the private int vertex count, which an integer that tracks the number of vertices which is being added into our graph. So the number of vertices in the graph, so that is being counted right there. After that one, I have the constructor main class here, which initializing a graph with a specified number of vertex. So this one here, what will be the size? And after that, I have the adjacency matrix new and size. So we are creating a size X as well times the size matrix. So the adjacency matrix as size X size times size matrix, where our size is the number of our vertex. So that is balance. And our vertices will be here equals new string size that we are creating an array for vertex label. So the vertices is an array with size element for storing labels of vertices here. And after that one, we have the vertex count as equals to 0. Since we start with no vertex, as no vertex have been added yet in that particular graph right now. After, I also do have the public void add vertex string label, which the method will add a vertex with a given label to the graph. So in this particular, we have the function there, use if else. So if our vertex count is less than the length of our vertices, so there is I actually assign label here to the vertex, to the current position in our vertex in the vertices array, diba? And I increment the vertex by 1. If there's no space, it prints a warning message as well that cannot add more vertices. After that one, I also do have here the method to add an undirected edge between two vertices by their indices. So this method here adds an undirected edge between the vertices at indices source, and we still have the destination. And we have here the if else statement, which is in our if I set the source and destinations are valid indices. So our source vertex, we check if indices are valid, and that will be indicated as 1 kung valid. So set 1 our source, which is go to the destination to indicate an edge. If they are equals, so if they are adjacent, we print as 1. Then we set, because the graph is undirected, meaning edge are bidirectional. So that's why we have here, we set vice versa for undirected graph in order for us to have it the same thing, since you can read that in a vice versa, the same thing, diba? And we after that one, here else we print, we have the warning message that invalid edge indices if there will be invalid in the future. And I also have here the display, the adjacency matrix with the vertex label. In that certain functions here, we have this part will print out will print the header of the row of the matrix, which is including the labels of each vertices. So makita mo na that later on when we will begin to run nga by row and by column na ni later on. So the outer loop, since we have here, this will be this part print the header of our header row of the matrix, which is including the label of each vertex. So after that, I have here the outer loop, which iterates over each row, representing each vertex, printing the label of the vertex at start in this particular line. The inner loop prints the values in each row. We have a nested for loop. The inner loop will print the value in each row, representing edges from the adjacency matrix, followed by a new line for each row. So that's how it being represented. Afterwards, I created the main function of main object here called a graph. So, which with a capacity of 4 vertices. So we are creating a graph with 4 vertices, and we add a vertex and we call the vertex function here, since we assign a label already. So this will be the vertex that we are supposed to add, the A, B, C, D. Then after we assign the edges, the particular function A to B, so A to C. So our graph edge is 0, 1. Then that representing the if 0, wala siya. If 1, wala siya. Amo na siya dapat. And so this is for A to B. And this is for A to C. And this is for B to C and B to D and C to D. So this will display the adjacency matrix. So this line here, add the edges between the specified vertex indices, creating connections as follows. So index ni gali naton ang diri, we are adding we specify we are giving the index 0 to 1, that must be A to B, excuse me. Then 0 to 2, and that will be C. So 0, 1, 2, 3. And 1 to 2 and 1 to 3. So this will be B to C and B to D and C to D. And after that one, we just simply display the adjacency matrix by calling the function for the graph display. So in our add edge, we call the add edge function, which we have here, the if else. Afterwards, if we'll begin to run that one, it will print out the matrix. So this one, we print out the rows and the columns. So we have here, since that is a non undirected, so this is symmetric, since we can transform the row into column as the same, something like this. So that's how it works. Is actually a simple program to represent the adjacency of matrix. So please just study about this. You can definitely study about this one in that way. In our future activity, you can also do have some background about that. So that's the end.